So far in this lesson, we've focused on the Java array data structure for managing collections of values of the same type. Now, a limitation of Java's arrays is that they cannot be dynamically resized. However, you can get around that limitation by taking advantage of one of the many classes in Java's Collections API, which consists of many different classes that are optimized for organizing, storing, and retrieving elements of the same data type. And one such class is the ArrayList class, which is a list data structure implemented underneath the hood as an array, but it provides dynamic capabilities for growing the number of elements based on the requirements of the program. So that's what we're going to be demonstrating in this next example. Now again, the ArrayList class is from the java.util package, and many of the classes in that package are so-called generic classes. A generic class is a class that's capable of manipulating a set of values regardless of what the type of the value is. So a list of items could be a list of anything. It could be a list of numbers, it could be a list of strings, it could be a list of employees in a company. So the ArrayList class and many of the other classes and interfaces as well that are defined in the java.util package are implemented in such a way that you can specify precisely what type of data you want to store in an object of that class, and then all of the subsequent operations in your code are type safe for that specific type of data. Meaning at compile time, if you were to provide the wrong type of data, you would receive a compilation error. So let's take a look at how we use the ArrayList class. And just like I did in the preceding example, I've already run the program and placed its output into a text file so that we can bounce back and forth between the source code and the output as we go. So at line 10 here, we show you how to create an ArrayList object. So notice first of all that you're declaring here a variable called items, and its type is what we would read as ArrayList of string. So the angle brackets following the class name ArrayList indicate the type of objects that we intend to store in the ArrayList. So it's an ArrayList that contains strings. And to create that object, we call the ArrayList constructor for an ArrayList of strings specifically. So new ArrayList, left angle bracket string, right angle bracket is the actual type name, and then the left and right parentheses indicate the call to the constructor. Now we don't have to specify the number of elements for an array list, although you can by placing a value inside the parentheses of the constructor. If in fact you create an array list and you don't specify the number of elements, it is automatically going to create an array list that has an initial capacity of 10 elements. That does not mean that it has 10 elements already in it. It means that it can store up to 10 elements before it will need to reallocate memory for additional elements. So basically it allocates enough memory for 10 elements, but it doesn't contain 10 zeros, for example, already, or 10 string values already. So after creating that ArrayList object, we start adding items to it. And there's a couple of different add methods. One that simply says take the value you specify and add it to the end of the ArrayList, and one that allows you to add an element at a specific index location within the ArrayList. Just like an array list is indexed starting from position 0. So this first call to add at line 12, because the ArrayList is initially empty, places the first string into the ArrayList. This next one at line 13 says to insert an element at index number 0, so that's going to cause the yellow string to be inserted before the red string in the ArrayList. So the list now contains yellow followed by red. And to prove that to you, we're going to display the contents of the list. And for our first walk through the list, we're going to use a counter controlled loop to do that, just to show you that you can iterate through the individual items in an array list, just like you can iterate through the individual items in an array using a counter controlled loop. So to do that for an array list, we declare a counter, in this case called I, initialized to 0, and we keep looping as long as I is less than the size of the array list. Items is the name of the array list, and its size method returns the number of elements physically stored in the array list right now. Now, because it's an array list of strings, each element is a reference to a string, and then the strings that are being referred to are the strings yellow and red that we added to the list. So we iterate through all the items, and one at a time we say to the items array list, get the item at position I, and the get method is going to return to you whatever type of object you said the array list stores. So because this array list stores strings, the get method will return a string. If I had an array list of employees, the get method would return employees. If I have an array list of integers, capital I integer, which is one of the classes in the java.lang package, then the get method would return an integer object in that case. So let's stop there and take a look at the beginning of our output. And you can see here that initially the list contains yellow and red, and we did that with a counter controlled loop initially. Now, we also have a display method that we defined in this example so that we could call it for the remainder of the example multiple times. And this display method receives two arguments. The first is the array list that we want to display, and the second is a description string that should appear before we display the contents of the array list. So let's take a look at our display method, which uses an enhanced for loop to demonstrate that these work with collections as well as arrays. So you can see that our display method receives as its first argument an array list of strings, which we're once again calling items here, and a string called header. We use the printf method to display the header. That allows us, because it's a printf method, we can use %n to specify a new line character in there as we did. And then at lines 51 through 52, you use the exact same syntax on an enhanced for loop for an array list as you do for an array. You have a variable that you declare of whatever type of elements are in the array list, in this case strings. So we have for each string, which we're going to call item, in the items array list, we're going to display that item. Then at line 54, after completing that, we will output a new line character by calling println with no arguments. So notice again, same exact syntax to walk through all of the elements of an array list collection as we used when walking through the elements of an array. And to prove that it worked, we go back to the output here, and you can see indeed we get the same output. So the next thing we do is add a couple of more items to the end of the list. And again, we're using the add method that takes an object as an argument and places it at the end of the list's current elements. So right now we have yellow, red, and then we go ahead and add green and then add yellow, and we display the contents of the list one more time. And now the list with the two additional elements is yellow, red, green, yellow. So again, green was added to the end, then yellow was added to the end. At line 31, we have a demonstration of the ArrayList class's remove method. With this method, you specify an object that you want to remove from the list, and it removes just the first occurrence that it encounters when walking through the list from the beginning to the end. So after doing that, at line 32, we call display once again to show you the current contents in the array list, and you can see that the array list now contains just red, green, and yellow, whereas before it had yellow at the beginning of the list. Next, we show you a version of the remove method that it uses an index number. So right now there's 3 items in the list, and going back to the output window, they're at index 0, red, index 1, green, and index 2, yellow. And in this statement, we're saying that we want to remove the item at index 1. So that's the middle element of the 3. And to prove that it was removed, we then once again display the contents of the array list, showing you that now it contains red and yellow, and the middle element green was indeed removed. At line 39, we demonstrate the contains method, which simply returns true if the ArrayList object contains the specified object, in this case red. So we're going to say whether or not red is in the list, and you can see that red is indeed in the list. It's one of the two remaining elements. And then finally, we just output the size of the list after all of those operations, and we can see that the current size of the list is 2 because it contains 2 elements. So these are just some of the many different methods that are available to us in class ArrayList. Let's go to the online documentation for a moment just so I can show you what the class ArrayList docs look like. When you see this notation following a class name, the angle brackets with one or more letters or words, possibly comma separated in there, that's an indication that you're looking at a so-called generic class. And in later lessons, we'll take a look at some generic capabilities and how to implement your own as well. But for most programmers, you're going to be focused on using the generic classes that are already built into the Java APIs. As with any other class, there's a list of constructors and methods that you can look at. So for example, if I go to the constructors, we used the no argument constructor, which simply says that we want to create a default array list with 10 elements of capacity to start. But you can also initialize an array list with another collections set of elements, or you can initialize an array list with a specified capacity. So if you know, for example, that an array list is going to contain, let's say, 1 million elements, you can specify that in advance rather than having the array list keep reallocating itself every time it runs out of space, and that can actually make your program operate a little bit more efficiently. And if you scroll down here, you can see the method summary, and you'll notice that there's quite a number of elements here. We demonstrated the 2 different versions of the add method, but there's also adding all the elements of another collection into the current one. You can clear the collection. You can make a copy of a collection by cloning it. We demonstrated the contains method, and as I scroll down, you'll see that there's lots of other methods here. And as with any new class that you're going to use, one of the things you're going to want to do is take a look through the complete list of methods and make sure that you have a general sense of what the capabilities of that class are.